Let's increase the richness of the approximating functions. Suppose that the approximating function class is all quadratic functions. F, parameterized by a, b, and c of x, just a quadratic in x, ax squared plus bx plus c. In terms of basis functions, phi1 is x squared, phi2 is x, phi3 is 1, and this function, ax squared plus bx plus c, is just a linear combination of the basis functions. Using the training set, the errors in the fit at each point are simply the approximating function at xi minus yi. Plugging in the expression for the approximating function gives the error explicitly in terms of a, b, and c. Stacking all the error components as a vector and writing this out with matrix multiplication yields a similar expression to what we derived before. Here, the value of the basis functions at the x-coordinates of the training data form a matrix, in this case an n by 3 matrix, that multiplies the 3 by 1 vector of parameters that parameterize the function class, and then the y-coordinates are subtracted off to produce the error. As before, the error criterion is the square root of the sum of the squares of the entries of E, in other words, the norm of E. So the task is to minimize, by choice of A, B, and C, the norm of E. Here it's written out explicitly, minimize over A, B, and C, which in least squares is written as the 3 by 1 vector x, the norm of a known array A times a unknown x minus a known array B. This is just like before, except now there are 3 parameters, and the matrix A has 3 columns. Let's look at the code. Call this quad fit, x data, y data, returns a, b, c, and the error. Fits a quadratic function, y equals ax squared plus bx plus c, to the data given by x data and y data. As usual, the code should check the dimensions. Here it's written as though they're both column vectors. Find the number of elements in x data and form the R matrix, which is the x data column vector squared, the x data column vector, and the ones vector, just as shown. Then use the backslash operator to solve for the optimal parameter vector consisting of little a, b, and c. Pull those out one component at a time, and finally compute the norm of the mismatch, r times the optimal parameter vector minus y data.